This is the Boeing 747, the largest commercial jet transport in the free world. Designed to meet the transportation demands of the coming decade, the 747 carries up to 490 passengers or more than 100 tons of freight at speeds in excess of 600 miles an hour. In designing the 747, full use of internal space was a challenge that had to be met before the airplane was offered to customer airlines. This film shows how one design objective was realized, that of using the area below the main deck for baggage and revenue cargo. In a sense, the 747 is an aerial train, airlifting people and goods and mail across a continent between breakfast and lunch, or spanning oceans between lunch and dinner. It is an airplane designed for the future, and the future is here now. The airplane is divided horizontally into 3 levels, or decks. The top level contains the flight crew's cockpit, with stateroom or lounge provisions immediately aft. The middle level is built as a continuous floor from nose to tail. This is the main deck. It is used for passenger accommodations or for cargo, depending on the airplane configuration. The lower level contains 3 compartments that are used for cargo, baggage, and mail. Or optionally, one may be used as a lower compartment galley, complete with elevator, temperature-controlled meal storage units, and refrigerated beverage lockers. The mechanized equipment you are about to see is standard for the 747. 2 compartments are fully mechanized, while a third or rear compartment is used for bulk cargo and is manually loaded. The internal configuration of the 747 was finalized after completing detailed analyses of many of the factors having a direct bearing on airline operations. In addition to the basic airplane interior, Boeing had to consider airport facilities that exist today and then project design thinking into tomorrow. Time and motion studies revealed control of baggage and cargo would result in more expeditious movement within terminals and between terminals and aircraft. This rather hectic condition is a typical baggage claim area and is being duplicated the world around. Unfortunately, every minute lost at a claim counter or in a cargo terminal results in a decrease in benefits from air transportation. And with new terminals and greatly increased facilities planned for the 1970 to 1980 time period, it is evident that a speed up in baggage and cargo handling must be accomplished. Containerization appears to be the logical answer. And cargo. It has been determined that faster handling of air cargo will be realized by the use of containers and mechanized systems for moving the containers in and out of aircraft. Therefore, the 747 lower compartment system was developed to eliminate delay factors, as identified by early studies, and provide user airlines with the most cost-effective means for baggage and cargo handling. Let's compare the forward compartment of the 747 with the test vehicle used to conduct loading tests. By constructing full-scale production hardware test vehicles and conducting tests that accurately simulate real operations, it is possible to assess the reliability of virtually every system before the airplane goes into service. To give you a clear picture of the forward cargo compartment, the front end has been left uncovered. And now let's look inside. This view will give you some idea of the painstaking work that goes into making a full-scale test vehicle. In airline operations, 747s may be loaded or unloaded from a variety of ground support vehicles, or at some terminals, specialized docks may be used. For test and verification purposes, Boeing used a side-loading dock that we're seeing now. Containers move parallel with the fuselage until reaching the entry door. At that point, they change direction 90 degrees. Here's the first container coming into the airplane. It is immediately followed by a second half-width container. Both are then moved aft. This provides room for the next pair of half-width containers to be moved into the airplane. The unique feature of this system is the power drive system. Lateral drive wheels move cargo across the threshold and fully inside the compartment. Then upon command by the loader, these wheels retract, and simultaneously the longitudinal drive wheels raise and translate container movement either fore or aft as desired. The lateral guides raise and lower in complete synchronization with the lateral drive wheels. As soon as the second pair of containers is fully inside, both are moved aft and the sequence continues. Now let's take a close look at the various components that make this mechanized system work. First, the control stick used by the loader governs the direction of container movement. The loader actually commands containers to move in or out of the compartment by moving the stick in the appropriate direction. Fore or aft stick movement causes the containers to move longitudinally within the airplane. Watch this container as it is loaded. Upon reaching the compartment threshold, rubber-tired guides contact the base of the container and move it smoothly into the compartment. Weight is evenly distributed over the ball transfer panels until the container reaches the far side of the compartment. Notice how the lateral guides keep the container aligned. Their use prevents any twisting or turning. This shows how the guides raise or lower as needed. The action is sequenced to control stick programming. As long as containers move laterally, the guides are in the extended position. When the loader directs containers to move longitudinally, the lateral guides automatically retract. As the containers start to move aft, a splitter bar separates the two container bases and positions them correctly in relation to the airplane's center line and outboard guides. These centerline guides serve a dual purpose. They keep the containers lined up longitudinally and serve as side and vertical restraints. This shows how the lips of the container base slide under the outboard guides. Such a restraint system is a far cry from the early days when cargo had to be strapped, bolted, roped, or clamped to assure immobility during flight. As the first pair of containers reach the end of the cargo compartment, they are butted against fixed end stops. Ball transfer panels in this system provide smooth movement of containers and pallets. Many tests were made to determine spacing between balls, ease of movement, complete load support, and compatibility with a variety of container base dimensions. A total of 18 electric motors are used to actuate the 36 pneumatically tired drive wheels. Each one-horse motor provides 2,400 inch-pounds of torque, or 1,200 inch-pounds per wheel.
That's right.
From a common shaft and turn the wheel. A component malfunction or the remote possibility of total electrical power loss was considered during system design. The T-handles being actuated here disconnect the power drive wheels forward of the door area, thus allowing manual movement of containers. These hand-operated releases function in a similar manner as the T-handle. Longitudinal drive wheels are disconnected in pairs. This precludes the release of all drive wheels at one time, since an engaged wheel provides a braking force. This is, of course, a safety factor and is particularly important should the cargo deck be at a slight forward or aft incline. In this power-off demonstration, drive wheels are in the freewheeling configuration. The half-width container weighs 2,830 pounds, which is maximum for this particular unit. We have discussed half-width containers normally used for baggage. Lower compartments of the 747 are not limited to this one type. Full-width containers can be accepted with equal ease. These larger units are more practical for stowing the bulky items. The use of full-width containers requires that centerline guide restraints and splitter bar be lowered. One man can raise and lower these spring-loaded units in a matter of moments. No tools are required, and the entire operation is fast and simple. Some loading operations may require use of full-width containers. Each has slightly more than double the cubic capacity of two of these half-width containers. Of course, the size of some air shipment items would necessarily preclude their stowage in the smaller units. Another optional feature of the lower compartment system for all 747 models is the capability of accepting netted pallets. This will prove particularly beneficial when interchange between 747 and 707 type jet freighters is required. An additional bonus is realized for passenger models because only one compartment is needed to carry the baggage of a full passenger load, thus providing two compartments for some 30 tons of revenue cargo. Looking directly down on the complete operation, the half and full-width containers are in position. Here comes a pallet, and it continues on. Full-width containers and pallets are restrained by the outboard guides. The intermix of containers and pallets is accomplished smoothly and simply. After the compartment is filled, the only manual action required is to set the hand-operated locks at the door sill area. Closing the door completes the loading sequence. The compartment you have just seen is representative of the 747 forward cargo hold. The hardware is the same equipment that's being installed in production airplanes. Just aft of the trailing edge of the wing is a second compartment. The total capacity is slightly less than the forward compartment, but the mechanized equipment is exactly the same. Now let's look at the rear compartment where bulk cargo is carried. This is manually loaded or unloaded, thus providing additional airline flexibility for last-minute or random cargo. As is the case in the other two cargo compartments, the rear bulk compartment is provided with adequate temperature and ventilation control, and therefore lends itself to carrying live animals, such as household pets. This is how the bulk cargo compartment is divided. Separator nets are secured in place as each section is filled, thus preventing shifting of the internal load during flight. Up to 5 men may be used during the loading or unloading sequences. During the time and motion studies conducted by Boeing, it was found that a mechanical loader would expedite cargo movement. But for load and unload functions at way stations, such equipment does not appear necessary. Having filled a compartment, the loader secures the divider net and moves to the next modular bay, where the operation is repeated. Finally, there is room for only one man to work. He completes the loading and secures the door protector net. The final step is to close the door and check it for security. Finally, in summary, each 747 airplane can carry 30 half-width containers, 16 containers in the forward compartment, and 14 in the aft. Each container has an internal volume of 173 cubic feet, and each can carry a maximum gross weight of 2,830 pounds. As an alternate, 8 full-width containers may be carried in the forward compartment and 7 in the aft. Volume of these larger containers is 350 cubic feet, each carrying a maximum gross weight of 5,680 pounds. A total of 9 pallets may also be carried, 5 forward and 4 in the aft compartment. This pallet capability is an optional feature. Either compartment may be loaded or unloaded in about 6 minutes. The back compartment has an internal volume of up to 1,000 cubic feet and may be loaded with as much as 14,000 pounds of cargo. It should be noted that the 3 standard models of the 747, passenger, convertible, and freighter, all have identical equipment in the mechanized cargo compartments. This type of commonality permits interchangeability of parts and precludes the requirement for specialized tools for servicing different 747 models that may be in any one inventory. The handling system you have just reviewed, along with other advanced features of the 747, will provide significantly better service to the traveling public and the airlines in the next decade.